Okay, don't adjust your YouTube, okay? This is free response question number 4. Before you do free response question number 4, they're going to give you a set of rules. The first two are kind of obvious. Assume things are real numbers, check. Trig stuff is measured in radians, check. Now, the third one is you will be given things that should be simplifiable. If you can simplify them, simplify them. For example, log base 2 of 8 can be written as log base 2 to the third. Base 2 cancels out, you get 3. You should be able to do that. Don't leave that like that. Cosine of pi over 2 is the x value of pi over 2, which is 0. You can simplify that. And the inverse sine of root 2 over 2 is the y value where you get root 2 over 2, which is pi over 4 and 3 pi over 4. So you can do those, guys. Don't leave your answers looking like that if you can keep going. All right. The fourth bullet says you can simplify these guys too. Like, don't be stupid and say, oh no, let's leave it as 2x and 3x. Oh no, let's not change it into that. Oh no, let's not change it into that. Oh no, let's not take the fact that if we add ln's, we multiply the inside. Simplify them if you can. Now, if you're not allowed to use a calculator. So obviously, you're not going to be expected to know what ln of 15 is, but you are going to be expected to combine things, add the exponents, subtract the exponents, combine like terms whenever you can. And for each part, show your work. There we are. So here we are. We're going to be given a bunch of algebraic situations that we're going to have to answer based off of the things that we're given. Okay, so this is part A, 1 and 2. We are given f of x. We're given g of x. 1 asks us to solve x if f of x is 6. So I'm going to take this guy right here, and I'm going to set 6 equal to ln of 9x squared. Now, first things first, I have ln all by itself with some stuff in the middle. I always like to take the e to the of both sides. I know it's not the grammatically most correct thing in the world, like that sentence I just said was, but that's what I like to do. If you would rather just write it out in exponential form, fine. It's the same thing. E to the ln of x is 9x squared, and you end up with e to the 6. Don't get your calculator out. You're not allowed to use one. I need to get x all by itself. Divide by 9, divide by 9. That crosses out. So you have e to the 6 over 9 equals x squared. Now, in order to get x all by itself, you have to square root both sides, and do not forget your positive or negative. Okay. Now, before you're like, I can't do anything. Sure you can. You could do two things, and let me write it over here because I'm out of space. You could do two things. The square root of e to the 6 is asking what times itself is e to the 6th? E to the third. Easily, what times itself is 9? 3. And you have plus or minus e to the third over 3 equals x. Wait a minute. Can I take this guy and plug it into that guy and have it work out? Usually when I have negatives and ln's and stuff like that, I'm not allowed to do it. Well, I have news for you. You are allowed to plug in the negative. Because before you take the ln, you plug in negative something and then square it, which makes it positive. So my answer is both positive or negative e cubed over 3. Now, obviously, we don't have a calculator. You can't simplify that. You can't do anything else with that. That is going to be our guy, and that's what we're sticking with. Okay, so kind of a tricky problem, but, you know, we did it, and I'm proud of us. Okay. Part 2 of part A has me setting this guy, which I know it's kind of faded, but you have 4 to the x plus 1 over 4 to the 5th equals, what was it, 16? Now I know what 16 is. 16 is 4 squared. And while I'm at it, why don't I multiply both sides by 4 to the 5th? Why don't I multiply both sides by 4 to the 5th? So I have 4 to the 5th times 4 squared equals 4 to the x plus 1. Just like we saw on this slide that told us all the rules that we were supposed to use, whenever you multiply terms of the same base, you add the exponents. And if you're like, what do I do? Should I get logs? Nope. If you have 4 to the stuff equals 4 to the stuff, set the stuffs equal to each other. So 4 to the 7 equals 4 to the x plus 1 means 7 equals x plus 1. Because you would log base 4 both sides, make the 4's go away, and this would just happen anyway. Subtract 1, x is going to equal 6. There's no rules here saying that I can't do this. And yeah, this kind of makes sense. I mean, if you were to go up here and say 6 plus 1 is 7, so 4 to the 7th over 4 to the 5th equals 4 squared, which is 16, which is what I'm supposed to get. Check, check, checkaroo. Now, checking this is not going to be near as friendly, but you could, if you wanted to, just trust me on that one. I did it right. Just trust me, please. I did it right. All right. All right, so what we have is h of x equals 6 log base 3 x plus 1, 4 log base 3 y plus 1, minus log base 3 z minus 4, and j of x is some trig-looking thing. One says express h as a single logarithm. Ooh, I like these. Whenever you're adding and subtracting logs of the same base, which, by the way, we are, step one that you always want to do is deal with the coefficients. If you have a coefficient, you can simplify that by making it an exponent. So you become log base 3 x plus 1 to the 6th power plus log base 3 y plus 1 to the 4th power, and nothing happens with u, minus log base 3 z minus 4. Then what you would want to do is organize all the pluses together and all the minuses together, and that's already taken care of. Step number 2 is if you add logs of the same base, multiply the inside. So this becomes log base 3. I'm going to put a nice little bracket here. X plus 1 to the 6th times y plus 1 to the 4th. We're going to leave it like that because I can't imagine we're going to be expected to FOIL this out 6 times, that out 4 times, then do a train wreck of a problem. I think we're okay leaving it like that. You're still going to subtract log base 3 z minus 4. Now, when you subtract logs of the same base, you divide the insides. So last but not least, our single logarithm is going to be log base 3, x plus 1 to the 6th, y plus 1 to the 4th didn't change. That's going to be over z minus 4 in an unnecessary parentheses, but now we have everything in a single logarithm. Hooray! I love it. I love it. And that's I. Double I is going to have me express this as a single trigonometric function. All right, whenever you're dealing with things that involve sine, cosine, secant, tangent, cotangent, cosine, you're going to want to change every non-sine cosine thing into its sine cosine version. So sine doesn't change. We still have 1 over sine x. Cotangent, however, is cosine x over sine x. Okay, so if I were to make believe that that's over 1, I know that that simplifies. So that leaves me with 1 over cosine x. Now, if you're thinking, that seems good enough to me, that is a single logarithmic function. Yeah, well, that 1 up in the numerator upsets me so. So remember, 1 over cos x is the same as secant x. So that's going to be our guy there. Just like that was our guy there. I love these. Oh, I love them so much. I love the algebra versions of these things. It just fills me with glee. This, on the other hand, is probably not going to fill me with glee. But we'll see what happens. Let k of x equals 6, the inverse cosine of x root 3, and m equals 3 inverse sine of root 3 over 2. Find the value of x in the domain of k that makes k of x equal m of x true. So I got to set these puppies equal to each other. Gross, 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 gross. All right, so I've got 6 inverse cosine x root 3 is equal to 3 inverse sine of root 3 over 2. Okay. I could divide everything by 3 if I wanted to. Might be helpful. I don't know. Maybe, maybe not. So that gives me 6 cos inverse sine of x root 3. That equals the inverse sine of root 3 over 2. Now, I know what the inverse sine of root 3 over 2 is. The inverse sine of root 3 over 2 is the y value on the unit circle. That gives me root 3 over 2, and that is pi over 3. So you become pi over 3. Okay? So I now have 2 cosine inverse x root 3 of both sides. I can divide both sides by 2, which kind of seems counterproductive. By the way, that's the same thing as multiplying by a half. So again, kind of seems counterproductive to what I did before. But now I have the inverse cosine of x root 3 equals x, or pi rather, over 6. Now, I need to somehow unlock that x. Now that I have all this cos stuff all by itself, I need to get rid of that inverse cosine. Well, just like we would use inverse cosine to get rid of cosine, I could use cosine to get rid of inverse cosine. It works the same way backwards. Okay, so you cross out, and we're left with x times the square root of 3 equals the cosine of pi over 6. I know what the cosine of pi over 6 is. The cosine of pi over 6 is root 3 over 2. I can divide both sides by root 3. So divide both sides by root 3. Okay, which, by the way, is the same thing as multiplying both sides by 1 over root 3. These cross out, and you get a half. X equals a half. So was this part fun? No, absolutely no. And this, again, is one of those things where the kids who get 5s will get that right. So great. You're not expected to get every single problem on an AP exam correct. So if you get to this point at the very, very, very end of the test after 4 multiple choice problems and 4 free response questions, and you're losing your mind and you're going insane, and if you look at that and you're like, nah, I don't blame you. But you can do it. Put your mind into it. This concludes the ultimate GOAT AP Precalculus practice test version 1.0. I'll probably make a 2.0, but this is the first one, so thanks for watching, and as always, I hope this helps.